Welcome, everybody. We're going to be working on Unit 4 today, which covers Chapter 5 in our book and introduces us to some new commands that we've never used before and some new concepts. The main focus is predominantly on using the insert, update, and delete commands. But we will also, by hook or by crook, learn also how to create databases from scratch and then create tables and define the data types for the columns in the tables. We're going to learn all of that tonight. We do like some more of talking about data types and table and database creation later on as well in more depth, but you need to be introduced to the concepts in order to do the homework, even though the homework kind of gives you some of the answers in a way. So we're going to start out with the create database command, which is kind of an interesting one. So I'm going to take us over to W3 schools here. And I see I got all my tabs are probably already open. I'm just going to reopen them from scratch. And the essential command for creating a database with SQL code is just as simple as what you see on the screen. So I think this is pretty interesting, right? It's just basically create space, database, space, and whatever you want to call that database, and then a semicolon at the end. And that command will create basically the foundation of the database. There's not going to be anything in it. There are going to be no tables, no data, but you've basically created the container for it so that you can build the other pieces. That's the create database command. So for example, if I want to create one called test DB, I would use this syntax here. Right, so that's a pretty simple one. Now, if you're wondering, right, and I've already been starting to get weird questions like this from some of you. Well, if I create the database and then I need to remove it, how do I remove it? Right. Well, so they also have a drop command. And so this is a really, really dangerous one, though, especially if you're the admin of a database and you have the capability to do this, because with one single line of code, I can destroy a gigantic database. That's kind of scary, right? But you will notice that with some of the pre-configured SQL files that we had been working with, that would automatically load a sample database. Inside there, one of the first lines was drop a database. It's like, why would you do that? Well, what if you had already opened the sample database before, and then you're trying it again, but we don't want to create a second copy because that won't work. So it drops the previous one and then creates the new one. So if you look at those pre-configured SQL files, you will notice that in there. So this is how you get rid of a database. Right? It's just that simple command. Now, after you have created a database, well, then you need to have some tables to put your data. And so there's a general syntax that we use. The command is create space table, and then you give the table a name. And then inside a set of parentheses followed by a semicolon, you list the column names as you want to call them. So you got to think about this a little bit. You don't just start, willy-nilly doing it. And then what type of data that column will hold. Now, we haven't had a very deep talk about data types yet. We're going to have our first sort of like not too deep version coming up here in just a minute. But you have to think about the kind of information that's going to go into each column. Is it a number? If it's a number, is it a floating point number? Is it a big number, a small number? What is it going to be, right? The other typical possibility is that it's words, like a string is what we call that. So alpha characters, like A through Z, upper or lower case, can also include numbers as well and other symbols, but generally speaking, text is what the other second major category is. There are some other data types, including date and date time and years. And for example, those are all modalities. And so there's some other little weird ones too, like Booleans and stuff, but we're not quite there yet. So we're going to be dealing with some pretty basic ones tonight, mostly either basic numbers or basic strings of characters. Those are the two that we're predominantly working with. So if I was to create in particular, a certain type of table. Here's a really good example. Notice that we have the create table command. We're calling the table persons. Then inside the parentheses, we come up with a list, right? So this would be the column name. So very common to have an ID field at the top of a table or the first row. And that often will be an integer. The counting number is an integer. And then things like last name and first name, they're characters. And then we preset the character field to hold a certain amount of characters. I do notice here, and I find this a little unusual from a database design standpoint, that they're allocating a whole byte of memory here. So up to 256 or 255 characters can fit into these fields. I would call that excessive. In reality, I think what's happening is in memory these days, even in a database, it'll occupy that much space anyhow. But in the old days, we always would be very, very careful because, we would limit how much you could put in there on purpose, because the smaller we would make our columns, the more data we could store in the database. That was always kind of the mindset. And also makes it run a little bit faster. So these are still considerations. So I would not typically use that value there. But notice that how they have, a mix of numeric and character fields. And they call this, by the way, varchar is kind of like the way the database people say it. Right. So that would create a table that would be like this. That does not contain any information at this point. We just have the structure. We just have the columns. Right. If you want to put information into the table, there's the insert command. That's what the insert command is for. We use the insert command to put stuff into a table. All right. So another thing in the book talks about this more than our examples will require for homework, but you can also create a table by running a query on top of it. So I can run a query on top of a different table, pull in the information, and then create a table based on that information. Well, that's kind of an interesting approach, right? And so we're kind of intermingling a query during the creation process. I would call this a little bit more advanced skill, but we'll look at it also through the book's PowerPoints a little bit too, where I think they maybe actually do a little bit better job explaining that. Now, as you might imagine, if you can create a table, you can drop a table, right? So you can use that very simple command to drop a very particular table from your database. So, I'm going to typically say that most often this happens when you're initially building it, and you might build a table you thought you needed, but then you maybe build a different one or whatever, and you can get rid of it. There's other commands too, like alter table. We're not quite ready for that one yet, but it is out there if you guys want to read up about it. All right. From there, I'm going to move to talking about data types, because as we're basically creating the columns in a table, we have to think about the information that they're going to hold, right? This is not done just for the sake of being a pain, right? This is done for very logical reasons. And originally, one of the stipulations was, like if you're dealing with numeric data and you want it to execute math as quickly as possible, you want to store it in a numeric format, which minimizes the amount of conversions that happen in memory from binary to decimal and all these like weird little computer geeky kind of things, right? Like this is like what, the essence of computer science basically is, thinking about those weird things. But for most of us, when we're putting stuff and we're storing stuff either on a spreadsheet or a document, even often when the information is numeric, it typically will get stored as text. And I think this is a really fascinating concept, right? So for example, we might think of like, if I give something an ID number, it should be a number, but says who, right? Could that number also contain letters? Sure, right? And if you might think of like a product number for something where it's a mix of letters and numbers. So a lot of times when we're storing stuff in a database, it often is text. It really drives most of it. So that's why they list this first. You will notice that there's not one type of text format. In fact, there's a whole bunch of different ones. The ones that we're mostly going to contend with, by the way, will be the first two. And I want you to just kind of look at why do we have two different ones? Well, the old school standard character, right? And you would declare a size on it, really maxes out with 255 characters. It's not really a lot of memory space. If you don't declare the amount of memory space, it only gives you one character. Right? So typically we use this one when we know the data is going to be small. For example, if I put, let's say in my database table, I want like a 2-letter abbreviation for state. I might set character 2 because it makes total sense. Very memory efficient. It takes a very small memory footprint. The other thing is it's fixed length. So in other words, if I say 2 characters, that's what's going in there. 2 characters, not 1, not 0, not 3, but 2, right? And so you have to have 2. So in the state of in the case of a state, that makes total sense. Now with the varchar, this basically holds the same information, and I could use it, like I said, I thought that was a big number before, to hold up to basically 65,000 characters in one single column if I wished, right? That's pretty excessive. But the important part of this is you can declare a size, and the size can vary up to the maximum of whatever number you set. So for example, if I cap it out at 100 and I type 101 letters, it's not all going to fit, right? Or if I set it to 40 and if it's 39, it will fit. If it's 41, it won't fit. If it's 40, it will. Right. So that takes a little bit of planning. The general kind of modern approach to this, which, for us old school people always makes us uncomfortable, is like, I just set it really big. Who cares? Right. We got lots of memory. We got lots of storage. We got lots of processing. Right. In the old days, we really had to think about that stuff, because if you would, only use like a 10% of that space each time, then you're wasting 90% of it in storage when storage was super expensive, right? So that's highly inefficient, right? So this still takes a little bit of planning. You will notice that they have other formats here, and we really don't generally use these in most of the stuff we do in this class. They're highly specialized, but notice that they have different kinds of meanings. But what you will see in almost every database is these two, the top two, a lot, quite a bit. And frankly, mostly this one in almost every situation. That's kind of the standard for text. All right. Let's move on to the numeric data types. And here we got a whole bunch of them listed right away. And I want you to notice that there's limitations to these. So why do you use a bit? It's only going to hold from 1 to 64. That's not really very big. Or they have what we call tiny ints, which goes from negative 128 to positive 127, 256 total values, by the way, when you include 0. Or Booleans, which is basically true or false done numerically. And so basically these two are the same. Not worried about this one at this point. The one that we are going to use tonight quite a bit is int, right? So when we have like a counting number, and it's got a very, very large capacity. So, I mean, I don't know how many, that's thousands, millions, 4 billion, 294 million, whatever values that a number up to that size can be stored in that. You will notice that they do have some terms that are interchangeable, which is a little confusing, but most database coders use this format. Very common. Like if you're doing the Java class for right now, if you're a web student and you're doing Java, this looks familiar, right? I mean, it's the same kind of thing. The difference here is we can declare its size. Very typically we don't, right? So we just say int, we don't worry about the size, it just is what it is. Another one that we'll probably use a lot in this class are the ones that you see here, float and doubles or decimals, right? Those are all pretty common. Floating point, doubles, and decimals have slightly different, capacities, but generally they work with numbers that have decimal points. And in some cases, when they have the second parameter here inside the parentheses, you can declare how many decimal places you're working with, So for example, if you're doing money, it's a real common one to use double and to declare the second parameter here as 2, right? Because you're working with 2 digits after the decimal point. And that's how the information is stored in the database. And think about it, that's probably what you want if you're dealing with money. It makes a whole lot of sense. All right. We also have the date and time data types. So for example, we've played with these already a little bit, in examples and stuff, and haven't really talked about it in depth. But date and date time basically hold a combination of, year, month, day, and the time. And really, that's all part of the same thing, So, like, you can, for example, issue a timestamp. So, like, you can have a timestamp that happens when you create a record and you can see when the record was created, right? And think of how useful that is. Like, if you had a retail store and the database is connected to your point of sale system, the moment a customer checks out, you're capturing year, month, date, and time. So you know exactly when it happened, right? Like, when was the sale processed, and it all travels with. Now, you don't have to use all aspects of date time, right? So you can kind of use this, just the regular date, right? Or you could use the regular date plus the time, right? It's really kind of relative to what your task is. If you were, like, for example, doing invoices, the date's probably fine. If you're doing point of sale, the date time might be very pertinent. So these are things we do think about. So those are the primary data types and the ones that we're going to be focusing on here. All right, now moving on to the main features of the night, and that is these commands that we're about to learn. And I'm going to kind of reinforce some of this stuff as we're coding through, and I'm hoping to get to the coding pretty quick here. First command is insert, and we'll call it insert into because that's kind of how the full syntax goes, right? So you say insert into, you choose which table you're inserting into, and then inside of set of parentheses, which columns in the table are we feeding the information into? And then a separate listing, also inside of parentheses, what information are we sending in? So for example, if I had a table that had first name, last name, address, first name, last name, address, then this should be the first name, this should be the last name, and this should be the address. And so they're going in relative to the declaration here. Also, this implies that if I'm inserting information into a table, I don't necessarily have to insert information into all of the columns. It can just go into certain ones. That's another possibility here. Now, if I know that I'm going to populate all the columns, and let's say in this case there were 3 of them, I don't have to have a list of which columns I'm pumping into. I just need to provide the data, which would imply then if I'm sending 3 pieces of information or 10 pieces of information, there are that many columns in the table, and I'm sending the information in the order that the columns exist, right? So the tables will have an order to the columns. Typically, it'll start with an ID field, right? ID, last name, first name, address, city, state, zip, etc. And then I would send the information in exactly in that order, not needing to declare the column names, right? So here's an example that they're using just to kind of drive this point home. So there's a customers table, and the customers table has at least these columns: name, contact name, address, city, postal code, country, and then the values are correlated. So Cardinal goes to customer name, Tom B. Erickson goes to contact name. This must be the address, this must be the city, this is the postal code, and this is the country. And so the information is traveling in the order that the columns are listed here, right? If I want, I don't have to, like, and I said this before, you don't have to put information into every column. You can just put them in the columns you want. So if I just want to put in the customer name, the city, and the country, and not worry about the other pieces of information, well, the ones that I omitted will come up null, provided, and here's kind of the caveat to this one, provided the table allows for it during the setup. We'll talk about that in a second, right? So when we're building the table, we would take that into consideration, basically. All right. The next command, and they talk about null values. Okay, what is a null value? When we are declaring our table structure, so you go back to the create command, we will often use syntax like department ID, integer, not null, right? Meaning you have to have that piece of information. Null is basically a way of saying the absence of anything. All right. The other command that we're going to look at, another important one, is the update command. And there's some special stipulations on this one, and they make a little note of it here, right? So the general syntax is you choose which table you're updating, and then you're going to set a value for a certain column. Sometimes you're doing math to set a value. Sometimes you're just saying, I'm going to put this value in column 1. I'm going to put this value in column 2. And then I can also add a query statement to it, basically when it matches a condition. So for example, if the invoices due minus the invoices paid equals 0, I might not, update that one, or maybe that's the one I want to update. So sometimes we can set conditions for it as well. Now, here's a little warning on this, and the book does the same thing. It says, be careful when updating records in a table. Notice the where clause in the update statement. The where clause specifies which record should be updated. If you omit the where clause, all records in the table will be updated. And that might not be what you want. In fact, most of the times, it's not what you want at all, right? Like, so for example, if I wanted to update somebody's last name because they got married, that's a real common one, right? I don't want to update everybody's last name in the table to the same last name. That makes no sense, right? So it's only where the condition meets whoever that person was. They have a little demo database here. So for example, if I ran the update command on this table, I would find the contact name and set it to Alfred Schmidt in the city of Frankfurt, but only if the customer ID equals 1. So, right, here's the customer ID. So this would be the record I would alter. And then the byproduct of it, you can see Frankfurt has been changed. And then the contact name is changed to Alfred Schmidt, right? So we only change the pieces of information we need to, and only when the query matches as well, where the where statement makes the condition relevant to do that. It is possible to update multiple records. So here's kind of a neat thought, right? So if I get a bunch of information in my database and I have a bunch of customers in Mexico and I want to update their postal code where the US postal code does not apply to Mexico, right? I might do this update. And so if the condition of the country of Mexico matches, then I take all the postal codes and just set them to 0, because this is not applicable for that country. That would be, so I can update everything that is the country of Mexico to a postal code of 0, right? So here in the US, we have postal codes like this. In a lot of the, you know, in a lot of Europe, the British provinces and stuff, they have these really weird ones like this, right? But those are still postal codes. And here's a really good example where you think about a postal code and you think it should be a number. That's kind of an interesting thought too. Doesn't have to be, right? Depends on where you live. Another one that's really dangerous, and this is the kind of like the warning one, right? So if I went and I said update customers and set the postal code to 000, it would literally do everybody in the table. Probably not what you want. And here's kind of the thing you have to think about in databases. Databases, unlike a lot of other IT structures, don't have undo buttons. So what there's no control Z in a database, right? I can be in a spreadsheet and mistakenly update everything, and I can control Z my way out of it, right? The undo button. In a database, once the information is written in the record, it's written in the record. And then guess what? You'll have to go back and probably manually fix each entry. Not fun, right? So super, super careful with the update command. And it's one of the reasons why we use a sample, or we build our own sample database to do the work in this chapter, because that way, if you mess it up, you're not destroying one of the other databases. All right, so that's the update command. The other one that we're going to work on tonight is the delete command. And this one is also one of those you have to be careful with, right? So just like the update command, the delete command is destructive. And if you don't specify a condition, you run into the situation where you might destroy more than you want. Okay, so for example, delete from a particular table where a certain condition is true. And so the condition becomes very, very important. So here's this customer table, the international one that we've been kind of looking at. And here's an example of how we might do a condition that would work without being destructive, right? So delete from, so notice the phrase delete from customers where the customer name equals Alfred's Futterkist, I think is the way to say that one. Kind of an interesting name. So if you look at the previous table example, he's there. In this one, he's gone. So they found that record where it matches, and any record that matches that, it will be deleted from the table. It is also possible, if you intend to delete everything in a table, you can just say delete from table name, semicolon, and it's blank and it's destructive. But sometimes, sometimes you do that. I'm going to say that happens more often when you're initially building a table than at any other point. All right, now the next thing I'm going to do here, just to kind of give you the connection between that material from W3 Schools and then the material from our own textbook. This is a fairly short PowerPoint, and I'm going to try to get through it super fast and show you the correlations in the material and what stuff in the chapter is basically not super important to us, at least at this point, right? The general objectives here are basically to create a copy of a table that can be used for testing, insert, update, and delete statements. That's not how we're operating. We are creating a fresh database and fresh tables because there's plenty to learn from doing that too. All right. So the general concept, assuming you already have a database, you can create a table using the create table command. And then you can also add to it query information. So in other words, if you're interested, let's say you have a table already and you want to make a copy of that table, you can use this second command here. So create table, and you notice how they're using the copy here. That's a pretty common convention. So I'm going to make a copy of the invoices table and then select all of the records from the invoices table to populate the new table. That's basically how it works, right? So if you're interested in doing that, I did get a question from, I forget who it was. I think it was George, and George is out camping tonight, if you guys are wondering. Hey, George. um, but he asked me, he goes, how can I do this and experiment with stuff? And I'm like, well, one way you can do it is to, you know, you can not worry about it. Okay. So, for example, we have sample databases that we were given. Well, you can just experiment to your heart's content, maybe even completely destroy one of those databases, but you'd still have the source file to recreate it. Right. So no worries there if you want to experiment. But if you want to try to be safe, you could make a copy of a table. That would be one approach, or to start something from scratch and see how it goes. That's not a bad idea. If you are looking to kind of ramp it up a little bit, so in other words, you want to create a new table, but you want to create that table with the results of a query from a different table. So like we've been running queries all along, right? And we get results, and it's often not the whole table. Well, you can turn those results into a table. That's what this command would do. So for example, we would create this new table called vendor balances based on the invoices table, and we are selecting these features, whatever those are, and then doing a little bit of math to qualify it, and then we're grouping it by vendor ID, and we're putting it all in this new table. So this is basically a way to take the results of a query and make a new table out of it. How often does that happen? It really depends on the database, but sometimes it happens, especially for reporting, I think is one of the common usages of that. All right. So now that the tables are created, whatever those are, we always have to think about, like when we're inserting information into a table, what are the columns? So sometimes you have to look. You have to actually look at the table and look at the design and figure out what are the columns and what kind of stuff goes in them. So you often will see when you're looking at a table information like this. So these would be the column names. All of these would be column names, right? These would be the data types. So the integer would be a counting number. There's that varchar, right? So up to 50 characters would fit in there. A date, right? So that would be year, month, day. A decimal number up to 9 in length with 2 decimal places after the decimal point, right? So common, for financial amounts. So payment total, invoice totals, those make sense to have, uh, dimes and penny placeholders, basically. There's I think that covers all the things here, but notice that we also have a couple of weird ones. We haven't learned about this yet, but you can set things like IDs to auto increment, so you don't even have to enter them. They just automatically add one each time. That's a thing. They also have ones that if you don't enter information, you can declare a default. So like, for example, if I put in a payment total and they don't make a payment, well, if there's no payment, what's the payment total? 0. Makes sense, right? To have a default in some circumstances. All right. But the point of the insert into command is if you're going to put in a column list, then the values that you're inserting have to match the type of data the table is expecting to see. So if I'm, the first thing I'm sending in, let's say up here, is the invoice ID, and I type, I don't know, hamburger instead of a number like 1, 2, 3, 4, it's not going to work. It's going to throw an error and will not allow you to do it. There's reasons why database designers, by the way, choose certain kinds of information. Well, think about it. If you're putting money into a column, I don't want to put words in there. That doesn't keep track of your money really well. Or if I'm gathering somebody's name, I really don't want math or a number in there, right? So these are just kind of common sense things, right? So example, once again, so insert into an invoices table these values. Here's all the values. Notice no columns were specified. This assumes we know what the columns are, what kind of data they receive, and we're sending them in the correct order. I don't need to specify it. Second example, the converse, right? I'm indicating all the column names in order, and all the data in order. What's fascinating about this is you can switch the orders around a little bit. I don't recommend that. I always like to keep things in table order whenever I do a query. It just makes the most sense. So if vendor ID comes first, well, that should come first. That's how my brain thinks, right? So either approach is fine, by the way. If you wanted to insert into a table multiple values and the column names, I can have a whole list of data that I send in. As long as it's in the right format, this would be one record, right? It's inside parentheses. You notice that? Notice comma at the end. This would be the next record, comma at the end. Next record, no comma at the end because we're done. And really, I would put a semicolon here, but that's me. Right? It'll work without. Now they go in and they talk here about the color sample table. So for example, they might have a couple of different fields here, but the same concept still applies. So for example, if I just want to insert one piece of information and just into the color number of an entry, I can do that. I just call the single column name and the value I'm throwing in which case is an integer, right? Color number, that's an integer, right? If I don't put anything in, the default is 0. If I want to put something in the color name, well, I can throw in text. Why? Because that's characters. If I want to insert something into each of the columns, but I don't want to really add anything aside from the word orange, what's the default color number? I don't know. That's going to become 0, right? That's the default is 0. Or for the ID, it's auto increment, so it'll add to it automatically. We haven't played with this one yet, but we will eventually. Right. So the point of this is you can, if you're not specifying, column names, I don't know if you're noticing that here, no column names, then the information must enter in the order that the columns exist, right? Which would be in that order. So it's helpful to know what's in the table. Sometimes you just look at the table, or if you wish, if you're in MySQL, you can expand the tree in the sidebar, and you can see the columns also. I think it's helpful to know the data types, though. But most common are numbers and strings. Another thing that they're going to, maybe hammer even more is that it is important if you're entering information into a table and you want to qualify it, right? So we want to add then basically a query statement at the end of it. So for example, like this person, if you take their invoice total, subtract the payment total and credit total, and if that equals 0, then I want to insert into this table under that criteria. So that's kind of the generalized format. So whenever you're doing these select statements, if you want to select specific columns, you can specify all the columns that you're selecting from which table, right? And I want you to notice it's not going into the same table. So I can grab it from a different table and then insert it into another table, right? I'm going to call that kind of a more advanced skill too, but that's totally doable, right? But that would only happen if this mathematical calculation equals 0. So there's the qualifier that goes with that. Now let's take a look at the update statement here, and I think they do a little warning, like we saw at W3 eventually here. But basically, if you're going to once again update a particular table, you call that table out by name, then you tell it what you're setting. So I'm setting the payment date, which is the column, with a date. I'm setting the payment total with this number, but only when the invoice number is this weird invoice number, right? And so the criteria becomes important here. If I omit the where statement, then every invoice's payment date and payment total will be the same. Not what I want. So this one, you got to be really, really cautious with how you build that statement, right? If you want it to affect, um, you know, one, as it says here, one column for multiple rows, right? So in other words, if we want to set terms ID to 1, we're only going to do that for this vendor. And that might have multiple rows affecting it still. So this is why you have to be kind of careful with these commands. I want you to notice that, and this is I think an important thing to read, and I think people maybe like gloss over it when they're reading the book, but it says by default, MySQL Workbench runs in safe update mode. So they make this assumption that sometimes database people screw up, and we're not going to let you screw up by mistake, right? So safe mode prevents you from updating rows if the where clause is omitted or doesn't refer to a primary key or foreign key column, right? So they're going to keep you from blowing away all the data. If you want to turn this feature off, it tells you where to go do it, right? We'll experiment tonight. Maybe we'll have enough time to try that, but maybe not. So that's just a fair warning, right? Because it does happen. You can do what I call kind of embedded queries inside of an update statement too. I think this is a little bit more advanced skill as well, and not something we're going to be trying tonight. But when you get to a little bit more advanced database level, these are very useful. And once again, the delete statement, right? Another one that you have to be very cautious with because you can completely delete everything. So it typically is recommended where you have a where statement to set a condition, so you're not accidentally deleting everything, and if possible, more than one condition to ensure that it's the case. We will learn about this other structure here, this query within a query. By the way, they call those subqueries if you haven't figured that out yet. Once again, the warning at the bottom of the slide, and this is the last slide, and then we're going to take a break, by the way. If you have that safe mode turned off and you don't have a where clause in your delete statement, you are blowing away all the data in that table. So caution, very much so. All right, folks, this will end the lecture bit of class. So I'm going to stop the recording here.